Hi guys, welcome to the new session. In today's session, we are going to talk about the relations. Okay, so we'll start with the very basics of relations, and the very basics of relation starts with the ordered pair. Okay, so let's start with the ordered pair. Okay, so first of all, how to define the ordered pairs? Okay, ordered pair, as the name says, pair. Okay, it's a pair of elements written or given in the fixed order. Right? What does it mean? Let's say that here I have two elements written in this order 5 4. Okay, now here the order is very important. Why? Because the order is fixed and I cannot change the order. Okay, so if the given ordered pair to me is 5 4, then I cannot write it as 4 5. Why? Because here the order is fixed. So if I wanted to write this order pair, I have to make sure that this particular order is maintained all the times whenever I'm going to use this ordered pair. But if I change the order to the new order, then it's going to be the wrong thing. Okay, so a pair of elements written in the given fixed order is the ordered pair, and the elements, they are enclosed within the brackets. Okay, so this is what ordered pair means. Okay, now I'm sure you know this thing about the ordered pair. Why? Because we use ordered pair in lots of places. We use ordered pair in coordinate geometry. We use ordered pair in relations, in sets, right? When we try to, or when we establish relations between two sets, or when we define relations between two sets, there we use ordered pairs. Okay, even in as what I spoke about in coordinate geometry. Okay, if we have to locate any point on the xy plane or the Cartesian plane, so what do we need? We need ordered pair. We need coordinates of the point. Okay, let's say that P is the point on this Cartesian plane, and P has a coordinate 5 4. Okay, so let's say here this is 1 2 3 4 5, and here 1 2 3 4. Okay, so 5 4 means that here I have this point P which has coordinate 5 4. Okay, now these coordinates, the coordinates I'm using here, they are ordered pairs. Okay, now because P point, it is represented by this ordered pair 5 4. What does it mean? It means the order is fixed. I cannot change the order. Okay, if I have to locate a point with coordinates 4 5, then it's going to be some other point. Okay, what I'm trying to say here is that P and Q are not same. Why? Because the here for Q, I have changed the orders. Now, if you want to locate this point Q on this XY plane, then here I have 4 and here 5. So it's going to be somewhere here, 4, 5. It's going to be somewhere here. Okay, this is Q. Now, you can see that these are two different points. P, right? P have coordinates 5 4 and Q has coordinate 4 5. Okay, same goes here with the relations too. Whenever you are going to see the ordered pair in the relations later on in the session, during the session, then you will see that the order of ordered pair matters. Why? For example, I will give you a quick glimpse of the definition of a relation. Relation, we say that, okay, relation, it is the set of ordered pairs. Okay, ordered pairs. Now, see here. Now, when we establish relations, then we need two sets. Okay, let's say that here, uh, I have I'm just taking one ordered pair. Let's say that 4 5. Okay, 4 5. Okay, and it belongs to some relation. Okay, let's say that this is the given relation, or this relation contains this ordered pair 4 5. So what does it mean? Now, if you see here the order is very important, because 4 5, the ordered pair 4 5 means that element 4 from first set is related to the element 5 of the second set, right? But if you tell me that, can you change it to 5 4 5 4, I cannot do that. Why? Because now how I will interpret it as, the element 5 is related to the element 5 of first set is related to the element 4 of the second set. So see here, the interpretation, it is totally different. Okay, so that's why when we use ordered pair, the order matters the most. Okay, I hope this thing is clear. We are going to dive deep into this. Okay, it's just the example. Okay, same here with the coordinates 5 4 and 4 5. They are two different points, right? So it goes the same with relations too. Okay, now see here one thing that is important that you must know is, let's say that I have two ordered pairs. Okay, let's say that I have two ordered pairs, two ordered pairs. Okay, now two ordered pairs. I have first ordered pair is A1 B1, and second ordered pair I have A2 B2. Okay, now these two ordered pairs, okay, these two ordered pairs will be equal when A1 is equal to A2 and B1 is equal to B2. Then we can say that these two ordered pairs are equal. Okay, I hope you understand it. Okay, so what I'm trying to say is that two ordered pairs can only be equal if the first element of the first ordered pair is same as the first element of the second ordered pair, and the second element of the first ordered pair is same as the second element of the second ordered pair. Okay, A1 equals A2 and B1 equals B2. Okay, so I hope this thing is understandable, this thing is obvious. Okay, now here let's talk about the next thing. Here is Cartesian product. Okay, that's the main thing, Cartesian product. Okay, Cartesian product. Cartesian product. Now, what is Cartesian product? Okay, first of all, in maths, there are different ways to multiply different things. I hope you agree with me. In arithmetic, when we multiply two numbers, we have multiplication tables for it. Okay, so whenever we need to multiply any two numbers, we take help of the multiplication tables to solve the given expression, right? Then in vectors, we also have ways to solve two vector quantities. We can use cross product, we can use dot product. When we deal with matrices, we have different ways to multiply two matrices, right? So same here, this guy, uh, Cartesian product, it was invented by the French mathematician named René Descartes. Uh, we have taken his name before too, if you remember, when we did the part of quadratic equations where we sketch the graphs of different polynomials on the xy plane. Okay, so it is named after the famous French mathematician named René Descartes. Okay, he's also known as the father of coordinate geometry. Okay, so he gave the idea that if you are given with two sets, okay, two sets, let's say that I'm given here with A and B are the two non-empty sets, okay? So let's say that here I have A. In A, I have set of elements 1, 4, 5, okay? Then I have another set B where I have elements A, B, okay? Now see here, now here you can ask me, what is set? Okay, now set, it's a collection of well-defined objects. For example, here I can say this is a set of numbers, okay, and here it's a set of English letters. Okay, so set, it's a collection of well-defined objects. Okay, I'm sure you know the definition, right? Then so the René Descartes, he said that if you want to find the product of these two sets, then it's possible. Okay, but we have to follow the different approach here. Means that we cannot use we cannot use the same method. We cannot employ the same strategy that we do in arithmetic. Okay, so he said, what we can do, the product of two sets, whenever we have to do that, then it means that we have to pair each element of the first set with every element of the second set. Okay, so if I have to find the Cartesian product of these two sets, it is going to be denoted by A cross B. Okay, how to read it? It is A Cartesian product B, but sometimes just for the sake, okay, of convenience, we call it A cross B, but the real or the accurate pronunciation is A Cartesian product B. Okay, so he said that if you are given with two sets, then the Cartesian product of two sets, it's going to be the pairing of each element of first set with every element of other set. Okay, what does it mean? Let's see here. For let's say that this is my set A and this is my set B. Okay, all right, so here I have elements 1, 4, 5, and in this set I have elements A, B, right? So if I have to find a Cartesian product B, then I have to pair every element of this set with every element of the other set. Okay, So here I have to pair one with A, one with B, then same goes for this 4. Okay, and then same goes for this one, 5. Okay, so A Cartesian product B, it's going to be 1A, okay, then 1B, 4A, 4B, 5A, and 5B. Okay, so this is A Cartesian product B. Okay, now see here the mathematical definition. Now I'm going to write the mathematical definition. Okay, now see here, so I can say that, okay, A Cartesian product B, what it's going to be, it's going to be, what are these are the, okay, this is a set of ordered pair. See here, 1A, what is it? It's an ordered pair, ordered pair, ordered pair. So it's a set of ordered pair. So it's going to be the set of ordered pair, right? Such that A belongs to A, right? And B belongs to B, right? So this is how to represent your Cartesian product in roster form, right? Yes or no? Okay, so this is just a mathematical way of writing the Cartesian product. Okay, just remember, whenever we have to find the Cartesian product, okay, of two sets, it means we have to pair each element of first set with every element of the other set. Okay, this is just the visual representation. Okay, see here I have mapped each element of this set with the every element of other set. I hope this is clear to you. Okay, and this is how you write in set builder form. Okay, so that is what Cartesian product means. Now here you have to understand few things. Now you have to observe few things here. Okay, and what are those things? Now here again, these are the two given sets, right? And here I have found a Cartesian product B. Now, a Cartesian product B, it is not same as B Cartesian product A. You have to understand this thing, okay? In arithmetic, we say that A cross B is B cross A, right? But here, it is not the same as what we do in arithmetic. Now see here why? Because if you are going to find B Cartesian product A, then what it's going to be? Okay, let's see it. This is set B. Okay, so this is set B, and here I have set A. Okay, so here I have B contains AB, and A has these three elements, 1, 4, 5. Okay, so now if you are going to, if you are interested to find B Cartesian product A, then it's going to be A1, then A4, A5, right? A4, A5. And then here B1, B4, B5. Okay, so it's going to be B1, B4, B5, 5. right? Now you can clearly see here that this is not same as a Cartesian product P, because here the order of the ordered pairs, it's different, because here we are just mapping the elements from B to A, and here we were doing it from A to B. Okay, so just keep this thing in mind, that the Cartesian product A cross B, it's not same as B Cartesian product A. I hope this thing is clear to you. Okay, now if this thing is this area visible to you? Let me check. Yeah. Okay, now see here, let's try to make few more observations here. Okay, now let's say that here I'm given with the set A, and it has two elements. It has three elements, 1, 2, 3, and then I have set B. It has three elements, 3, 4, 5. Okay. Now see here, the number of elements in set A, it is represented by NA. Number of elements in set A, it's going to be 1, 2, 3, 3. And the number of elements in set B, it is represented by NB. And how many elements do I have here? 3. Okay, so number of elements, okay, in Cartesian product of A cross B, it's going to be NA multiplied by NB. Okay, so it's going to be 9. Understand? You can use the same formula here. Again, same for B cross A. Why? Because NB Cartesian product B Cartesian product A is going to be NB multiplied by NA. Okay, so let's apply this here. We have 3 elements, here we have 2 elements. So N A cross B, number of elements in Cartesian product AB, it's going to be 3 times 2, 6. See here, 1, 2, 3, 4, 5, 6. Right? Same for B cross A, 1, 2, 3, 4, 5, 6. Okay, so 6 and here 6. So always remember that number of elements in the Cartesian product, it's going to be the multiplication of the number of elements present in the two sets. Understand? Okay, so if this thing is clear to you, then let's move to the one more thing here. All right. Okay, so what I can write here is that Cartesian product, okay, it is the set of ordered pairs, right? And how do we form these ordered pairs? By pairing each element of set A with every element of set B. Every element of set B. Okay, provided that A and B are 2. A and B are 2 non-void set or non-empty sets. Okay, non-void sets. Okay, so just remember this thing. Okay, and the mathematical definition in the set builder form, it is the same, where I can say that A cross B, it's going to be AB, okay, such that A belongs to A and B belongs to B. Okay, as simple as that. Okay, now uh, let's say that I have two sets. Okay, I just want you to understand few things here is that let's say that I am given with set A and set B. Okay, my set A is 1, 2, and set B is 3, 4. Okay, now see here, if I have to find A Cartesian product B, then I have to make pairs of 1 with every element of set B. So it's going to be 1, 3, 1, 4, then 2, 3, and here 2, 4. Okay. Now, if I take any ordered pair from this Cartesian product A cross B, I can say that that particular ordered pair is going to be the subset of A cross B. What I'm trying to say here is that here I can say that one ordered pair 1, 4, it is subset of A cross B. Right? Same 1, 3, it is subset of A cross B. 2, ordered pair 2, 3, it is subset of A cross B. And ordered pair 2, 4, it is subset of A cross B. Why? Because I have taken this ordered pair from this set. So these ordered pair are the part of this main set A Cartesian product B. So that's why here I am saying that these ordered pairs are the subset of main Cartesian product A Cartesian product B. I hope this thing is very obvious, and I'm sure I hope that you agree with me. Okay, now come to the definition of relation. What does it mean, relation? Okay, because the definition of relation in books, it is vague and and incomplete, I would say ambiguous. Okay, so what is relation? Okay, what is relation? Relation. Okay, so relation, the definition of relation is that the the relation the relation from non-void set A to non-void set B is the subset of A Cartesian product B. What does it mean? We will try to figure it out. Okay, I'm erasing this. I'm sure you know what does it mean, Cartesian product. Okay, now, okay, so we will come to this definition later. Okay, later. First, we'll start with the basic. Okay, because this definition, it is vague. Okay, because this definition is true, but it's a little confusing. Okay, now see here, when we talk about relation, okay, relation, we have to understand that a relation is defined between between two sets. Okay, so if I give you one set and if I ask you to establish the relationship, then you have to ask me where is the other set. This is the minimum requirement to establish relation. Okay, the minimum requirement is that we need two sets and those sets must be non-void sets, means that the sets should not be the empty sets. Okay, now what does it mean? Here I have set A. Okay, this is my set A. This is my set B. Okay, in set A, I have elements 1, 2, 4, 6. In set B, I have elements A, B, C. Okay, and let's say that R is the relation from set A to set B. Okay, so if R is the relation from set A to set B, so how to write it? See here. So R is the relation and it is the relation from set A to set B. Understand? So this is a way to write the relation. It's a mathematical way to write the relation. So whenever you see something like R relation from C to D, it means R is a relation and this is a relation defined from set C to set D. I hope this thing is clear to you. Okay, now see here. Now, relation between two sets, what does it mean? This set has element, this set has elements too. So relation between two sets means that the relationship between the elements of these two sets, right? So it means that how elements in this set, in set A, are related to the elements in set B, right? So let's say that here, it is already defined that the relation is given and A is related. A is related to this A. 1 is related to B. 2 is related to C. And 4 is related to B. And C is related to C. Okay, so then what's going to be the relation? Again, relation, it is a set of ordered pair. Again, it is, now I have to see here, this is the relation from set A to set B, and I can see clearly from this figure that A is related, element 1 is related to the element A, element 1 is related to the element B, element 2 is related to element C, element 4 is related to element B, element 6 is related to element C, right? So here I can say that here element 1 is related to A, so it's going to be the ordered pair 1A. Here 1B, 1B. Here 2C, okay, 2C. Here 4B, 4B. Here 6C, 6C, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so in this relation, I have 5 ordered pairs. Okay, now come to the definition. It says that relation from non-void set A to B, non-void set A to B, it's the subset of A cross B. Okay, what I want you to understand is that if you take the subset of, sorry, if you take the Cartesian product of these two sets, now see here, what does it mean? Cartesian product means that you have to pair each element of this set with every element of this set. So it's going to be 1A, 1B, 1C, here 2, sorry, capital, 2A, 2B, 2C, 4A, 4B, 4C, and here 6, right? 6A, 6B, and 6C. Okay, now if you look at the relation, it is the subset of A cross B. Now look at all these ordered pairs that are in this relation. Now, if you see 1A, is 1A here? Yes. Is 1B here? Yes. Is 2C here? Yes. Is 4B here? Yes. It's 6C here? Yes. So I can say that the relation, this relation is a subset of A cross B. That's what the definition means, okay? And this is applicable for all the relations. You can, whatever relation you are given with between two sets, when you will get the relation in the form of set of ordered pairs, you will find that the relation that you are given with, it is the subset of the Cartesian product of the two sets. Okay, so that's what the definition says. The relation from one set to another non-void set, it is the subset of two sets, of Cartesian product of two sets. Okay, now let's take an example. Okay, let's take one example. Okay, let's take one example. Now, see here, when you will do questions on relations, the relation will be defined by the person who will give you the question, okay, or by the examiner who will set your exam. Okay, what does it mean? Let's say that I'm given with two sets. A is 1, 2, 3, and B is 3, 4. Okay, now see here now I am defining the relation here. Let's say I'm an examiner, so here I'm going to define the relation here that R is defined as that it's going to be, it's going to be the ordered pair Y, okay, such that, okay, for all, or such that X belongs to A and Y belongs to B, and X is less than Y. Okay, X is less than Y. Now this is the relation defined. Okay, now whenever you will solve the question, the relation is already defined in the question. Here the relation is already defined. Now what I will do here is that I'm given with the sets, so here I will just I will use the visual representation of these sets. Here A, 1, 2, 3, here B, set B, 3, 4. Right? Now, the relation says that you have to find, okay, this relation is from set A to set B. Okay, set A to set B. Okay, and the relation says that you have to find all the ordered pairs such that the first element of the ordered pair, it comes from A, second element of the ordered pair comes from B, and it must satisfy the condition the first element must be smaller than the second element in the ordered pair. Now see here, if I pair 1 with 3, 1 comes from A, yes, 3 comes from B, yes, and is 1 less than 3? Yes. So the pairing is possible. Okay, so 1 will get paired with 3. Okay, or element 1 will get related with element 3. Understand? And next is 1 and 4. Now, is 1 belong, does 1 belongs to A? Yes. Does 4 belongs to B? Yes. Is 1 less than 4? Yes. Okay, same here, 2, 3, and 2, 4. Why? Because 2 is less than 3 and 2 is less than 4. Now see here, now go here, take the last element 3. Now, does 3 belongs to A? Yes. Does 3 belongs to B? Yes. Now see here, now is 3 less than 3? No. So I cannot pair this 3 with this 3. Okay, so this will only get paired with this 4. Okay, so from here my relation is going to be 1 ordered pair 1 3, 1 4, 2 3, 2 4, then 3 4. Okay, so you can see here that this all the ordered pairs in this relation, it's a subset of A cross B. If you are going to, sorry, it's a subset of Cartesian product A cross B. If you will find Cartesian product AB, then you will see that this relation is a subset. Okay, so now see here, this it is. Now see here, there are ways to represent the relation. Okay, now relations can be represented. Okay, so it can be represented, number 1, visual representation. So this is the visual representation. Okay, then next is your set builder form. Set builder form. So which one is set builder form? This is set builder form. See here, this is set builder form. And then number 3 is your roster form. Okay, which one is the roster form? This one. Okay, so a roster form, it's a form where you arrange elements in the form of the list. Understand? So there are 3 ways, because a set can be represented in 3 ways. So relations are also represented in these 3 ways. Okay, so I hope it made sense to you. Okay, now see here, there is one very important thing here, is that how many relations are possible from one set to other set. Okay, but to understand that, I just want to tell you something. Let's say that I'm given with this set. Okay, let's say that A is the given set to me, and this set has 2 elements, 1, 2. Okay, now if I want to find the subsets of this set, what could be the possible subset for these sets? Okay, so here the possible subset could be what? It could be the possible subsets would be 1 null, right? Then it would be 1 2 and 1 2, right? So I can, because I can represent it with PA, means the power set, right? Because power set, it contains the subsets of the given set, all the subsets of the given set. So if A is the given set, then the set of all the subsets of A is represented by PA. Now see here, here I have two elements, okay? Number of elements here is 2, okay? And here 1 2 3 4, okay? So number of elements in power set, it's going to be 4, okay? Because now see here, this is null, okay, wide, right? So of course it's going to be the part of this set, means it means nothing, okay? So it's possible that you take 1 or you take 2 or you take combination of 1 and 2 or you take nothing, okay? Now here, the thing here, what I'm trying to tell you is that if, now listen very carefully, let's say that here here NA represents the number of elements in the set, then the number of elements or the number of subsets are going to be 2n, okay? This is very powerful thing, or this is very important thing. Number of subsets or total number of subsets, it is equal to 2 raised to power n. Now this thing is derived from permutation and combination, okay? So as now I don't want to go in that detail how to derive this, but just I have shown you here that this is because we have to make combinations, right? So here, just rough idea to let you understand how it could be done, okay? Just remember here that if you want to find the total number of subsets for any given set, and if n is the number of elements where n represents number of elements in the given set, then total number of subsets, it's going to be 2 raised to power n, okay? 2 raised to power n. So here total number of elements in set A, it is, see here, it is 2, okay? So total number of subsets, it will be 2 raised to power n, 2 raised to power 2, which is 4. See here, 4. Okay, now why we are doing this? Now, because the question arises that how many relations can we make from set A to set B, non-void set A to set B, and the definition says that the relation means the subset of A cross B. So if we know the total subset of A cross B, it means we know how many relations can be formed, right? What I'm trying to say here is that, let's say that, here I'm given with two sets, A, 1, 2, 3, and here B, A, B, okay? Now here, n of A, number of sets, here it is 3, here, sorry, number of elements, here B, in this set is 2, okay? Right, now, if I have to find A cross B, A Cartesian product B, then number of elements going to be in this Cartesian product, it should be NA multiplied by NB, okay, which is equal to 6, right? Now, I know that, I know that, that I know that the number of elements in this set, because A cross B, it's a set of ordered pair. Cartesian product is a set of ordered pair, and here I have 6 elements in the set, right? So the total number of subsets, going to be 2 raised to power 6, right? And 2 raised to power 6, it's going to be 64, means that you can have 64 relations, okay? You can have 64 relations from set A to set B. You can make 64 relations from set A to set B. Understand? So these are the possible relations, number of possible relations you can have from one set to other set. I hope this thing is clear to you. So from here you can say that total possible relations from set A to set B 64, because relations means subset of A cross B, right? And here we know how to find the total number of subsets, so that's going to give us the possible number of relations. Okay, now there is one more thing. Domain range and codomain. Okay, now see here, what does that mean? Domain, range, codomain. Now let's say that here I have set A and I have set B. Okay, here I have 1, 2, 3. Here I have 4, 5, and here I have 0, 1, 2. Okay, now see here, now here I'm defining a relation, there is a relation R from A to B. Okay, so, and it is defined in the way that it contains the ordered pair where X, such that X belongs to A, Y belongs to B, and X is less than Y. Okay, X is less than Y. So see here, X is less than Y. So is 1 less than 0? No. So 1 is not going to make relation with 0. Same here. So 1 is going to have relation with 2. Here 2, it's going to have relation with, is 2 less than 0? No. 4? No. Okay, and here, here I can use one more, 3. Okay, so see here, R is going to be, is 1 less than 2? Yes. Is 1 less than 3? Yes. 1, 3. Okay, so 3. Is 2 less than 0? No. Is 2 less than 1? No. Is 2 less than 2? No. Is 2 less than 3? Yes. So it's going to be 2, 3. Then is 4 less than 0? No. 5? No. So here we are just going to get these ordered pairs, right? Now, this relation means the set of ordered pairs of the relation from set A to set B, right? Now, domain. Now, what does it mean? Domain. Domain, it is represented by dr, or I can dr or domain r. Why? Because it is domain of your relation. Okay, so domain of the relation means the first element of the ordered pair. Okay, the first element in the set of the ordered pair. Okay, so it represent, okay, here it represent the 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 first element of the ordered pair. Okay, now you can see here was the first element 1, was the first element 1, was the first element 2. Okay, so here domain, it's going to be 1, 2. Now domain, it's going to be 1, 2. Okay, then comes number 2, it is range. Okay, now range, it is represented by range of relation. Okay, and it represents, okay, it represents the second element of the ordered pair, okay. So what's going to be the range here? Now see here, 2, 3, 3 means 2, 3. Okay, so here range, it's going to be 2, 3. Now there is one more thing. Now the elements that are in the range, sometimes we call these elements image. Say, let's, okay, see here, we can call it that 2 is the image of 1, 3 is the image of 1, 3 is the image of 2. Understand? So for when relation is defined and the elements in first set are connected or related with the elements in the second set, then the elements of second set are going to be images of the elements of the first set. Okay, so here we can also say that 2, and here I'm writing the point here, element 2 is the image of, element 2 is the image of 1, right? Is the image of 1. Element 3 is the image of 1, and element 3, it's the image of element 2. Understand? So these are also known as the images. Okay, same way these are known as the images, the elements in domain are known as pre-images. Okay, see here, if 2 is image of 1, then 1 is pre-image of 2. If 3 is image of 1, then 1 is pre-image of 3. So here you can also use pre-image. Understand? Then codomain. Okay, now codomain, it's very simple. Codomain contains all the set of elements. Okay, this whole set of elements is the codomain. Okay, so codomain here, it is going to be codomain R. It's going to be the set of all the elements. Okay, so it's going to be 0, 1, 2, 3. Okay, means set of all the elements present in this set. Okay, means this whole set. So codomain, it's going to be the whole set. Okay, whole set B. Now see here, if you look at the range, right? If you look at the range, now I can say that here range, it is the subset, or it can be same as your codomain. Why? Because range, see here, what is the range? 2, 3. So range, it's a subset of your codomain. It's a subset of this set, right? Because if you will make a subset of this set, so 1, 2, 3, 4, 2 raised to power 4, they are going to be the 16th subset, and it's going to be the part of that subset. So your range can either be the subset of your codomain, or it's possible that your range is same as your codomain when all the elements in A are have their images with all the elements in B, right? So this means the range, it can be same, or it will be the subset of your codomain. Okay, so these are the basics. I hope this has given you some clarity. Okay, and here just remember your domain, it is always going to be the subset of your set A. Okay, so this is going to be the subset of this A, or it can be same, as set A. When, why I'm saying same or equal, because it's possible that all the elements in set A are related to the elements in set B, then the domain, it's going to be the whole set A, right? So just keep these things in your mind. So I hope you understand the basics of the relations. In next lecture, we are going to learn the types of relations, and I will see you in the next class. Okay, thank you very much. Have a great time. Bye-bye.